Hi, this is Mike Mulholland, and today we're going to look at how to combine the equations for the steps of a multi-step reaction into the overall net equation for the reaction. And you may find that you need to go full screen on watching this video, or all this stuff here will be too small for you to read. So here's an equation that someone asked. Given these two steps, how do you combine them to the net equation? This was 3.5 years ago. Nobody's answered it. Why not? Because it's impossible, because there's a mistake in the question. So first thing we need to do is find that mistake, fix it, and then we can answer the question. So the first step is quite simple. So I already took care of checking if the equation was balanced, but now let's look at the second step. So we have 6 times 2 is 12 carbons, plus 3 carbons is 15 on the left. And this formula is written in this funny way to try to tell you something about the structure of the molecules. There's 1 carbon, 2 carbons, 3 carbons, times 5 is 15. Hydrogen. Here we have 6 times 2 is 12, and 4 times 2 is 8, total of 20 hydrogens. And the right side we have 2 plus 1 is 3, 5 of them, 15. Here's our problem. We'll come back to that in a moment. But let's check oxygen. So here we have 3 times 2 is 6, and 4 times 1 is 4, total of 10. And on the right side, 5 times 2, total of 10. But here's a problem. And remember that if we could get another 5 on this side, it would be balanced. So this formula is written the way it is to tell something about the structure. Let's try drawing out the structure. And so we have the CH2 group here, the CH. Carbon wants 4 bonds, so we get a double bond there. Connect to this carbon, double bond to this oxygen. Carbon's got its 4, this oxygen has its 2. But this oxygen isn't happy. It wants 2 bonds, it's only got 1. Now, if you have studied organic chemistry, you might recognize this looks a lot like a carboxyl group if there was only a hydrogen there. So let's put a hydrogen there, making this a carboxyl group, which is a common thing in organic chemistry. So now I think this is right, and I'll tell you why. 3 reasons. One is every atom in this molecule has the right number of bonds, unlike in what we had before. Second, this is the formula of a known substance, namely acrylic acid, whereas this didn't correspond to any known substance. And third, 1 additional hydrogen atom per molecule, and there's 5 of them, gives the 5 H's we need to make the second step a balanced equation. Okay, so now we fix the mistake. We go on, how do you combine those steps to get the equation for the overall reaction? So this is, each step is balanced. And if you start combining them, as long as that aspect is maintained, the steps are balanced, the overall will be balanced. If we add these together now, overall would be balanced. If we multiply this one by 2, this one by 3, whatever, even if we reverse this one, add them together, they're still balanced, because if the steps are balanced, any sum of the steps will be balanced. So that's not what the net equation is about. What the net equation is about is first identifying something that's a product of the first step and a reactant in the second step. In the second, then here it is, acetylene here, C2H2. Second, We need to multiply the two steps by positive integers so that the amount produced in this step and used in this step is the same. So that we can cancel that out. That's what's going to make it a net equation. And once the amounts are the same, we cancel that substance out, add them up, and we're good. Now, you might have noticed that H2O appears twice as a reactant. So since they're both on the same side, they're not going to cancel, but you might think we should combine those. And you'd be right. But if we combine them now, we'd get 6, and that's not right because we need to adjust the relative amounts of the two equations before we combine these two instances of water. Okay, so what's the thing that is a reactant in each step? We already identified it, C2H2. We need to make the amount of this substance produced in the first step equal to the amount used in the second. How do we do that? 6 of them here, 1 of them there. So we can do that by multiplying the first equation by 6, and the second one, trick question, by 1, because we're already good if we multiply that one by 6. So we'd have a 6 here, and this becomes 12, and 6, and 6, and that 6 is going to cancel that 6. And what's going to happen with the water? Now we can combine them. We got 12 there and 2 there, 4 there, for a total of 16. So if we add this up, this is what we get for an overall net reaction. You notice that the acetylene that's produced in the first step, used in the second step, is not in this overall equation. That's what makes it net. If we did it right, as we said, our result will be balanced, but I did check to make sure it was balanced, and it is. So thank you for watching.